I'm going to talk a little bit about the XSEDE resources that are coming online just recently. They are still in early stages, Jetstream and bridges. So I'm going to show some of the use cases, and they're a bit different from the traditional HPC cases that people have used on this supercomputer. So that's why it would be interesting to take a look at these resources. And as Alan has shown kindly, we have the map of the various resources that XSEDE has. And we at Cleveland is essentially smack in the middle of the whole thing. And we are connected through the 100 gigabit connection through all these other locations. So I think we are in a very good position in terms of making use of these resources and also utilizing it for either class or research purposes. And like Alan has mentioned, these non-traditional HPC users are where NSF is trying to focus some of the resources and also the effort in terms of getting new users. So as you can see, this graph shows that the traditional HPC users are on the left side. This side, and it's probably like less than 10% of the whole users of computational resources. And these have been heavy users that have made use of the available supercomputers heavily. But what about the people that probably just use their laptop, but then they want to scale up a little bit, but not necessarily to the level of the high HPC, or they still want to use Windows, for example, or they still want to use their local operating system. What's in it for them that XSEDE can offer? So they go ahead and take a look, and they say, okay, we can offer you self-provision, scalable science and engineering environment. You can define your own environment, essentially, and you can make use of it according to your objective. So the first resource that I'm going to talk about is the bridges, which is located at Pittsburgh, at PSC. And as you can see, again, this side is more traditional HPC that has a lot of big data, either data acquisition using, for example, telescope. You get lots of information about stars and things like that. You can also produce data using simulations or modeling. But some of these other applications are not typical, right? You have Facebook, Twitter, video feed, library stacks of books or documents. So these are the targeted area of research focus. So some of the typical motivating use cases includes data-intensive applications or data collections, gateways that Alan has mentioned before as well. So if you want to have your gateways for other users to make use of your tools, for example, Red Hat, it's possible to create your own gateway and have it being hosted on these resources. You can run machine learning or graph analytics, essentially a lot of things. And also, you can have your own database server placed there. So typically on the HPC, you don't have your own place to put your database. You have to probably import it here and put it in your database. But in this case, you can actually also ask for a database resource. So this is a fancy, colorful graphics of what bridges computational resources. So as you can see, the bulk of it is actually on this bottom. They have 800 nodes that are capable of running a lot of data crunching applications. And that's the typical, if you want to do machine learning, there are some GPUs as well. But you can also see that it has web server nodes, for example, and also database nodes that you can make use to construct the gateways for your application. And also VMs, right? If you want to run your own web server, you want to have your own VM that controls what is being outputted into the web. This can also be used to control your database. So either KVM or Docker or OpenStack are possible. If you don't know about these terms, that's okay. And then, as Doc has mentioned before, you can have your pick of what big data tools that you want to use. Spark, Hadoop are certainly a couple of the big words right now. If you don't want to have a database, or you want to have database on top of it, you can also have that. So, some possible things. Here's an example of a use case. You have on the left side the interface with the users. On the interface itself, you want to have the web node managing how the web output would look like. And behind that, you'd have the database node that store the data, get ready for any query that the users would issue. And that way you can construct a whole integrated system, essentially, that serves the purpose of your gateway. So this is about bridges. The second one is about Jetstream. Jetstream is a similar thing to what bridges has in terms of it's not for non-traditional users. It's still part of the NSF Extreme Digital Program. But in a sense, it really emulates the Amazon AWS service. So if you're familiar with it, it essentially provides you the capacity to, hey, I have a certain allocation of certain number, right? And then from that number, you can actually start your instances, which is your own VM. And then this VM will be provisioned using standard OS or your own image, for example. So this is a very interesting offering. The Amazon AWS will also give you some other perspective. But I think the point is this is an option for us, for researchers, essentially to, hey, I don't want the traditional HPC. I want to have some playground for me to have my own website or my own science portal. And this is one way to have it. So NSF made a conscious decision to cater to this additional non-traditional users that have not been reached using the traditional HPC. About 300,000 researchers have used the resource, but only about 1.5% actually is using that among all the possible resources, researchers. So Jetstream will be a new interactive cloud-based system that through its scale and flexibility will dramatically enhance the diversity and size of the US researcher community benefiting from the XSEDE resources. So any size of VMs, 1 to 44 cores, they can create virtual machines out of their own or just make use of the available image from the library. Educators, for example, if you want to teach classes that requires small computation, it's also an interesting thing because you don't have to teach the students how to use Linux. They can just make use of the available software applications that might be driven from the web. These are possible science domains: biology, earth science, GIS. You can run CyberGIS and have it as a separate portal, for example. If you are in the medical field, if you are aware of Galaxy, for example, that's also another web portal that you can put on this resource. So you can have it for you only, but you can also open it for a member of your groups, for example. So that's why it's so flexible in terms of the usage. So Jetstream is actually located in a couple of places. Indiana University, that's one, and then the other one is in Texas. So there is also another development area in Arizona. But these are all connected through the internet to 100 gigabit network. So there shouldn't be any issue accessing them. So this is an example of the interface and the location of your queries. So I'm going just to give a short demo on what it looks like. So I have an allocation on the XSEDE just because I'm a campus champion. Like Alan said, if you need certain allocations just want to try these resources, you can come to me, and I can assign you the access to it. So this is my dashboard on the Jetstream. So as you can see, it has my name at the top. And you can launch new instance. You have selection of images, not too many at this point, but you can have a choice, and then it will, for example, allow you to launch it, for example. But I'm just going to show an example of what I've created already. So I have CentOS 7 VM. This is just one core. You can have fun with it, essentially. You can SSH into it. There is this access to do the shell that has issues connecting with it. But trust me, you can SSH into it. And I'm going to show a Galaxy. And if you're, how many is familiar with Galaxy, actually? A couple of you, right? So you can go to this IP address. And this is actually the same. Just making sure 168.63, right? So that's also at the top 148.63. You can get data from the regular data location that you are getting. For example, this is a variation just to get output. Send query to Galaxy, and then it will automatically do that for you. So you can see on the history on the right side that it's actually importing the data from UCSC, which is in Santa Cruz, California. And it's being imported to somewhere in Indiana. I don't know where. But the point is we can make use of it. It's available. It's very easy to provision it. It probably takes a few hours to actually set it up. So rather than use the Galaxy server on Penn State and you have to wait, for example, for it to be available, this is one way for you to just create your own resources and run with it, essentially. So that's why it's a very convenient possibility. Now, it is in the still early user stage, both Bridges and Jetstream. But if you are already familiar with some of these resources, you are free to ask and get those resources. Just come to me. Okay? Any question?
What's the storage limit for the Galaxy if we want to set up our own Galaxy system?
So with XSEDE, you have allocations which you can use at one go, essentially, or you can parcel it into smaller chunks. So in this case, let me go back to the launch an instance thing and just go back to the image. And there is a Galaxy standalone here. So just choose that. It will ask that you request for a certain instance. You cannot be too small just because of the memory requirement and also storage requirement. Now, if you do launch and do Galaxy 2, so you can have these instance sizes that are already defined. So you can say, hey, I want 480 gigabytes of disk. It's possible to do that, but you might be using all of your allocation at once, right? So you just have to know what you want. For example, if you just want to try, for example, you can start from this one, which is the minimum size. But once you are ready to go with the production, you can then ask for the larger resources that goes with it. I think you can also ask for additional storage because this is only on the node itself. But you can have additional storage that attached to it, and that much is pretty much up to you. Again, you can say I need like 1 terabyte of space, for example, and that's still part of the allocation that you ask. So hope that helps. Any other question? Now, of course, the nice thing about Jetstream is it's free. Again, you just have to request for allocations. You probably have to write up proposal to get the allocation. But at the same time, this is still a very early venture of XSEDE. So it's not as mature as AWS, for example, that the AWS people will tell you. And so it's really up to your usage. But again, this is an option for you, and a great option at that, I think. So, any other question?